Next, in subtopic carboxylic acid, synthesis or preparation of carboxylic acid. Okay, so this subtopic means that we want to prepare carboxylic acid from other functional group using a difference of reagent. So the main point, the main target, we want to synthesize the carboxylic acid. Okay, first by oxidation of primary alcohol, aldehyde, alkenes and alkyl benzene. First oxidation, primary alcohol. So this is the general equation. Okay, how to prepare or how to produce the carboxylic acid from the primary alcohol. Okay, react with this reagent so to produce carboxylic acid. So here is an example for the preparation carboxylic acid. Okay, 1-hexane hexanol. Okay, react with this condition and reagent and produce this carboxylic acid. Number 2, by oxidation of aldehyde. So from aldehyde, this is the general equation, aldehyde. Okay, by using these several of oxidizing agent. Okay, so to produce carboxylic acid. Okay, oxidizing agent means that you using the agent which have a more oxygen in the reagent, so replace this hydrogen proton from aldehyde to become carboxylic acid. Here are some of example. You can study and please make sure you understand the general equation of the oxidation aldehyde to produce carboxylic acid. Okay, so number 3, by oxidation of alkene. So reagent, here is the reagent we're using in oxidation of alkene. Okay, oxidation of alkene. Okay, general equation using potassium manganate. Okay, heat reflux to form carboxylic acid, and also there are 2 carboxylic acid. Okay, and the other one, okay, when there are 3 alkyl group attached on C double bond C after cleavage. Okay, after cleavage this double bond, so the product are ketone and carboxylic acid. Okay, this one is symmetry. The position of alkyl group are symmetry and cleave. After cleave, okay, cleave because of we using the condition of heat, so produce 2 types of carboxylic acid. Number 2 is oxidation of terminal alkenes. Okay, terminal means that the double bond at the end of the structure. Okay, germinal means that the double bond is center of the structure, at the position center of the structure. Okay, this one case for terminal alkene means that the double bond C double bond C at the end of the structure, so react with this condition and reagent to form carboxylic acid and other side product. So in this oxidation of alkene, there are 2 types. First, oxidation of alkene. Okay, number 2, oxidation of terminal alkene. This one for germinal means that the position C double bond C at the middle of the structure. Okay, so the double bond will cleave because of a condition of reflux or heat, so the products are carboxylic acid. 2 types of carboxylic acid or the same carboxylic acid produced. While if there are many substituents, so the product become ketone and carboxylic acid. Here are example. Okay, so for this oxidation of alkene, it's very easy to memorize. Okay, for this one, okay, this one is terminal. Sorry, this one is the case for germinal at the center. So what happened? Cleave on the C double bond C, So you need to fill with this oxidizing agent at the end of the cliff C double bond O. Okay, and also it's become OH due to the oxidizing agent. Okay, next is oxidation of alkyl benzene. So here alkyl benzene oxidized become benzoic acid. So using this condition and reagent, okay, so here is general equation for alkyl benzene react in this medium and then form carboxylic acid. Oxidize, so it will be oxidized by using this reagent to form carboxylic acid. So, order for alkyl benzene to be oxidized, it must possess one benzylic hydrogen, which is bonded directly to the benzene ring. So, this one no benzylic hydrogen, and then directed to the benzene ring. So, if we react with any kind of the oxidizing agent, so there are no reaction occur. Means that R group not be in the form of benzylic. If in the form of benzylic, so there are no reaction, no product for oxidizing agent. Okay, next is how to prepare the carboxylic acid from the hydrolysis of nitrile. So alkyl halide react with sodium cyanide to form nitrile first and then undergo hydrolysis in the condition of acidic solution to produce carboxylic acid. So there are two steps. First, we want to form nitrile. We need to react this alkyl halide with sodium cyanide to form nitrile and undergo with the hydrolysis in acidic solution. Hydrolysis means that we add OH on the structure, so will become a carboxylic acid. Important here, so this method is not suitable for converting aryl halide to benzoic acid because aryl halide is not reactive to the nucleophilic substitution. On this general equation, so this reaction can be occur by using nucleophilic substitution. If this alkyl halide are from the aryl halide or benzoic acid, so the reaction is not occur due to the aryl halide is not reactive for nucleophilic substitution to occur. So here is the condition of the nitrile reflux with the dilute acid to produce carboxylic acid. Okay, we're using the strong acid, sulfuric acid, and also chloric acid. Here is the example for the hydrolysis of nitrile. Okay, this alkyl halide, aliphatic alkyl halide, react with the sodium cyanide to form nitrile. So this nitrile will undergo with the hydrolysis to form carboxylic acid and side product ammonium ion. So for base hydrolysis, so this is condition for the base hydrolysis, means that we're using the any kind of the base, strong base such as OH minus in condition of reflux and heat. So the product will give the C double bond O, O minus. This one is the carboxylic ion and side product is ammonia. Only for the condition of base hydrolysis. It's different for acid hydrolysis. If we using the strongest acid, so the product is a carboxylic acid. If we using the base, strong base on the hydrolysis, so the nitrile will turn to the carboxylate ion. So next, how to prepare carboxylic acid from carboxylation of Grignard reagent. In this preparation, we need the Grignard reagent. So this is the chemical equation for Grignard reagent, RMGX, okay, plus carbon dioxide in the presence of acid will get the carboxylic acid product. Okay, so only applicable for primary, secondary, tertiary, allyl, benzyl and aryl halide only. Okay, so the mechanism in this preparation, we're using the nucleophilic addition. Okay, we want to add alkyl or aryl magnesium halide to double bond C double bond O to form carboxylate ion. So the condition, the reagent must be using this Grignard reagent. Here is the mechanism of the carboxylation. Okay, Grignard reagent, okay, react with the carbon dioxide to form this one, carboxylate ion in salt form, and continue with the presence of proton. So end product is carboxylic acid. Okay, so here are example of the Grignard reagent. Okay, so this one is R group, Mg is metal, and chlorine, X is halogen, react with the carbon dioxide, and also the presence of proton, source of proton will give the carboxylic acid. Okay, so the previous shows that the simple mechanism involve nucleophilic addition. Okay, this Grignard reagent add on carbon dioxide to form the carboxylate ion and give source of proton to stabilize this intermediate product to give carboxylic acid.